Let's start today with projectile motion in motion in plane. So let's start with our question number 1. It says a bullet is fired from a gun at a speed of 280 meter per second, right? So let me just write here initial velocity. Initial velocity of the gun over here is 280 meter per second. Great. Next is in the direction 30 degree above the horizontal. So theta here is 30 degree above the horizontal. The maximum height, you have to find the maximum height. So we know from projectile motion the maximum height of the formula for the projectile is u square sin square theta upon 2g, right? Now let's substitute. They have already given the value of g. Value of g is given as 9.8 as per the problem, and sin 30 is 0.5 or half, right? So let's substitute our given data. Here it will be u is 280, so 280 into 280 and sin square theta. So sin theta is how much? Sin 30 degree is 0.5. You can make it half, so 1 by 2 into, I am just making it half so that it becomes quite easy for us to solve, right? So 2 into what is g? G value is 9.8, so let me substitute here 9.8, right? So let's cancel out this 2, it will be 140, and here 2 it will be 140, right? And let's simplify it further. So 2 into 70, correct? So this will give us here a 00, 7 4s are 28, and 9800 upon 9.8, right? Let me remove this point here and make an extra 0 in the numerator. So this will give us 1000 meters. That's the maximum height. So let's see if there is any option. Yeah, option B is the correct answer for this problem. Let's see, if you have not watched the previous one for the vectors, you can go through the previous one, okay, in the playlist. Let's see the next question now. Next question says a car starts from rest, okay. So anyways, it's saying it's starting from rest, so let's keep it as u equals to 0. That's our initial velocity. If it is starting at rest, initial velocity must be 0, and accelerates. A is equals to 5 meter per second square. That's the acceleration. At t equal to 4 second, fine. A ball is dropped out of the window by a person sitting in the car. Great. What is the velocity and the acceleration of the ball at t equal to 6 seconds, right? And they have also said take g equals to 10 meter per second square. So let's take it in a little bit realistic situation. Let's assume that our car is there, okay. In the car you are traveling with an acceleration of 5 meter per second square till t equal to 4 second, because at t equal to 4 second you are throwing something out of the car, right, out of the window of the car. So let's imagine that the car started like this from here, okay. Let's say this is our car and it started from here, and when the car, it is t equal to 0, and when the car reached at this point, okay, let's say this is our car reaching at t equal to 4 second. Now you are dropping something, right? So when the car is stationary, our object's velocity, initial velocity will be 0, the object which you are throwing, right, the ball which you are dropping. Moment you reach at t equal to 4 second, the time when moment it reaches t equal to 4 second, it will have the velocity. What will have the velocity? The ball will have the velocity of what? Of the car, right? So if the ball is dropped down, it will have the velocity, and that velocity will be horizontal velocity. Sir, why you are saying that way? Because the car is moving horizontally, so the velocity will be only contributed initially to the horizontal direction, right? So let's find the horizontal velocity of the car, final velocity of the car at t equal to 4 seconds. So let's use our equation of motion, v equal to ux plus axt. Let me remind you, this is our same equation, v equal to u plus at, right? And since we are moving along the horizontal direction, along x axis, so I have assumed that velocity, final velocity will be equals to ux plus axt, where ux is the initial horizontal velocity, ax is the acceleration of horizontal direction, that's the acceleration of car, right, and t the time at which we are finding the velocity. So vx will be equals to ux, that's 0, ax is how much? Ax is 5, and t time is 4, right? So that will become 20 meter per second. Now this is the velocity with which the ball is thrown outwards, or ball is going outward in the horizontal direction, right? So Vx will be equal to 20 meter per second. Now if this is the horizontal velocity, be very careful, this will be the initial velocity with which the ball is thrown outside, right, along x axis at t equal to 4 second. Great. So is there any horizontal acceleration of the ball once it's thrown out? No, because it's no more the part of the car, right? So at that point, when it is thrown outward at t equal to 4 second, the horizontal velocity of the ball will be 20 meter per second. And at t equal to 6 seconds, since there is no acceleration, if you apply the same equation v equal to u plus at, the acceleration of the ball in the horizontal direction will be 0, and in that case our final velocity is still 20 meter per second. Many people have confusion with this. Let me repeat again. When you are throwing the ball outside the window, what happens basically? Now there is nobody to apply the force on the ball other than gravity. We will talk about gravity along vertical direction. But here we are right now focusing on horizontal direction. So there is no one. If there was a force, let's imagine that if there was a force, even after you have thrown the ball outside, the ball will be traveling in the horizontal direction, but it is falling down. It's not traveling in the horizontal direction along with the car, right? So here acceleration along x-axis will be 0, and that's why the velocity along x-axis is assumed to be 20 meter per second till it touches the ground. So t equal to 6 seconds, still it is 20 meter per second. Now when it falls down, be very careful. When it falls down, now initial velocity along y-axis is 0, yeah, because you are dropping it downward direction. You are not throwing it, you are not forcing it in the downward direction, right? If it was so, they will mention in the question, but right now initial velocity along y-axis is 0. And what's the acceleration along y-axis? It's 9.8. They have given something 9.8 or 10. Yeah, 10 they have given. So let's assume that our acceleration in the downward direction is 10 meter per second square. That is acceleration due to gravity. So Vy in the downward direction will be u plus uy plus ayt, right? And what is our acceleration? Sir, acceleration is downward 10. And time, sir, what you will take the time as? See, time we are throwing it at 4 seconds, and when it is going throughout, when it is falling down, t will be 2 seconds more, right? Because 6 seconds they have said. Let's go back to the question. The question says, what is the velocity and acceleration at t equal to 6 seconds? So we are focusing on when it is falling down. So it is in the air for 2 seconds. Be very careful. Okay, because before 4 there was no vertical motion, there was only horizontal motion. Once you have thrown it outward, after 4 seconds it falls down, right? So in 2 seconds, let's calculate how much will be the final velocity. That will be ay is 10 and t is 2. So that will be equals to 10 plus 20, and that will be how much? Our initial velocity along y-axis is 0. So that will be 0, 0, and that will be equals to how much? 20. So velocity along y-axis is 20 meter per second. Now velocity along x-axis is 20 and Vy is also 20. Let's find the resultant. So we can write a vector V vector that represents this velocity 20I plus 20j. So the resultant magnitude of this will be V will be equals to root under 20 square, that's 400 plus 400, or in the other way, if you don't want to do it like this, you can make it as 20 square plus 20 square, right? And that will be nothing but let's just call this 20 square as an apple. 1 apple plus 1 apple, so 2 apples. So 2 into 20 square, and that will be equals to how much? 20 root 2 meter per second. That will be our velocity, right? So this is our correct answer. Let's see if there is any answer. Yeah, what is the velocity and the acceleration? See, at t equal to 6 seconds, when it is in the air, the velocity was 20 root 2, that's fine. But acceleration is purely acceleration due to gravity. There is no acceleration due to the horizontal motion, because it's no more the part of the car, right? So the correct answer is option A. That is 20 root 2 meter per second falling downward, and 10 meter per second square, that's the acceleration due to gravity acting downward in direction. I hope you understood this part. In case if you have any confusion, just go back and watch it again. Let's see the next question. Great. The next one is very beautiful problem. The problem says 2 bullets are fired horizontally and simultaneously towards each other from the rooftop of 2 buildings 100 meter apart and same height of 20 meter with the same velocity 25 meter per second. Great. There are many same, right? And we will focus on them, each of them once again. When and where will the 2 bullets collide? Okay, now let's break this problem. The problem says here there are 2 buildings. Okay, I'll just read the question once again for you. So just let me first draw 2 buildings. These are 2 buildings, let's say, and they both are 20 meter, right? 2 buildings, 200 meters. 200 meters. The size of the building is 200 meter here and 200 meter over here, right? They both are of same size from the ground. So basically, why they have given this height? In a simple sense, when you are firing the bullet, we are assuming that the bullets are thrown from the same height from the ground, right? So that is 200 meters, great. And 100 meter is the separation between them, okay. And both of them are fired with a velocity of 25 meter per second, that is fired here 25 meter per second, and that is also fired here 25 meter per second, right? Let's reread the problem and understand the concept. The problem says two bullets are fired horizontally. Horizontally means I have made the arrows not perfectly horizontal, but it should be perfectly horizontal like this and this, okay. The white arrows will give you the direction of bullets. Both the bullets are fired horizontally from the rooftop of two buildings. Both buildings I have made 100 meter apart. I have mentioned over here it's 100 meter apart, okay, and of 200 meter height, okay. Both the buildings have a height of 200 meters and both are projected at velocity of 25 meter per second, right? When and where will the two bullets collide? Here we will use the concept of relative velocity, right? Now for relative velocity, because they both are approaching towards each other, when two things are approaching towards each other, we use the concept of relative velocity. So if one object is traveling with the velocity of Va in this side and another object is traveling in this side with the velocity of Vb, the relative velocity will be Vab, you can say, or relative velocity will be Va minus Vb, right? Va minus minus will become plus Vb, right? If both are approaching in the same direction, it's Va minus Vb, and both are in the opposite direction, the velocities will add up. So it will give you Va plus Vb. Now what's the velocity here? Va, sir, Va is 25 and Vb is again 25. So 25 plus 25, that will give you 50 meter per second. That's the relative velocity of both the bullets, okay. Okay, I hope you are clear with the concept of relative velocity. So this is relative velocity, and what's the relative distance between them, sir? The relative distance between them is 100 meter. Both have to cover up this 100 meter. So the relative time, the time at which they both will meet up, that will be relative distance upon relative velocity, right? So relative distance is 100 meter and relative velocity is 50. So after 2 seconds, they both will meet up, okay. So after 2 seconds, that's our time. So time we got as 2 seconds, great. Now the question says, where will the two bullets will collide? So let me just give you a rough idea that let's say after going like this, they will both come and meet at this point, right? This is the point, okay, after 2 seconds. But they are asking, where will the two bullets collide? Now look at the option. They are not asking this horizontal direction, like, right? They are asking the vertical direction, height of how much from the ground, this vertical. So in the vertical direction, can you tell me what is the initial velocity of the bullet? Think about it. So initial velocity is 25, but that 25 is in horizontal direction, not in vertical direction. We have not projected the bullet upward or somewhere at any angle, right? So that's perfectly horizontal. So what's the initial velocity along y-axis before they started moving? So that is 0, right? So the the vertical direction, the vertical height they will travel will be uyt plus half ay t square, right? Ay is what? Acceleration along vertical direction. What's the acceleration along vertical direction? So that is g, that's 10, right? So I'm just calculating the magnitude, though they are falling down, so you can take the negative sign. So it will be 0 plus half, and ay is at 10 and time is how much? 2. So 2 2s are 4 here, correct? So this will give us here how much? That will be our 20 meters. Now this 20 meters, now many people will think that 20 meter is the correct answer and option B is correct. No, 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 no. Be very careful. You started the motion from the top. So this distance, this height you got is from the top, it has covered up this 20 meter. Let me repeat again. Since the initial velocity is taken from the top and the time is also 2 seconds, it is traveling down, right? So that time it will go 20 meter from the top. So 20 meter from the top means 180 meter from the ground. So here they have said the height is from the ground. So here the correct answer will be 180 meter from the ground. So that is our correct answer for this problem. I hope this is clear. In case if you are not clear with, go back, just watch it again, right? Let's see the next one. When an object is shot from the bottom of a long smooth inclined plane, let's draw inclined plane. So let me just make an inclined plane over here, okay. Oh, what happened? I think something happened. So let me just remove this part. Okay, great. Let me just roughly draw it. So let's say this is our inclined plane over here, okay. This is our inclined plane. I hope you are familiar with the inclined plane. Kept at an angle of 60 degrees. So let's say this is our 60 degree over here. with the horizontal, it can travel a distance of x1 along the plane. So, you are throwing an object and that object is thrown from this end and it travels a distance of x1 over here, right? Great. But when the inclination is decreased to 30 degree, so let us imagine the same here with 30 degree, great. And if you are throwing again the object, it is traveling how much? X2 here. Then what is the ratio of x1 and x2? I hope the question is clear. Again I am repeating, there are two inclined planes, one is 60 degree, another is 30 degree. You are throwing the first one at 60 degree with some initial velocity, and the initial velocity is same as per the problem, the same velocity they are projected, right? So, what will be the ratio of the distance travelled? Now, you have to be very clear with the concept that if something is following an inclined plane, the acceleration in that case is g sin theta. In case if you have done laws of motion, I hope you are familiar with the force which is acting downward is mg sin theta, right? And if the force is mg sin theta, it is equals to ma. So, acceleration will be g sin theta. This is one way of understanding this. Another way of understanding this is, sir, g here is acting downward. So, here the component will be g cos theta and downward the g component will be g sin theta. This is another way of understanding the same thing, right? So, acceleration is g sin theta. When you are throwing it in the first case, so let me write here first case. Let us use the equation of motion v square minus u square equal to 2as. I hope you are familiar with this equation. Now, what is v? Sir, v is 0 because it is going and coming to rest at that point. x1 is the distance. If v was not 0, it would have travelled more, right? So, the v is becoming 0 and the distance is becoming x1. So, here it will be 0, u let us call it as u only, and 2g sin 60 degree into x1, right. This is our equation number 1 in the first case. I hope this is clear. 2g sin theta is acceleration, right. Let us see the second case. In the second case, we have again using the same equation v square minus u square equal to 2as. V is again 0, u again the same velocity as per the problem, 2g sin 30 degree, right. And this time the distance travelled is x2, correct. This is our equation number 2. Now, if I divide both the equations, equation 1 and equation 2, on the left hand side 0 minus u square, this will give you straight away minus u square, 0 minus u square again minus u square, right. When you divide both of them, you will get 1 here on the left hand side. On the right hand side, g and 2 both will cancel out, this 2g will cancel out with this 2g, right. And you left with sin 60 over sin 30 x1 upon x2, right. Let us cross multiply. So, this will be x2 upon x1, that will be equals to sin 60, sin 60 is root 3 by 2, sin 30 half, let us cancel this 2 with 2 and we left with x2 upon x1 is how much? Root 3 by 1. And but they are asking, I think x1 is to x2, yeah. So, you have to reciprocate both the sides. Let us reciprocate it, x1 upon x2 will be 1 by root 3. I hope this is clear. So, the ratio is 1 is to root 3, and is there any option? Yeah, option B is correct, 1 is to root 3. I hope this is clear to all of you. Let us move to our next problem. Great, beautiful problem and very simple problem. The x and y coordinate of a particle at any time are x is equals to 5t minus 2t square, right, and y is equals to 10t, very good, where x and y are in meters and t is in seconds. The acceleration of the particle at t equal to 2 seconds. So, let us simplify it in an easy manner. You can write it as I cap j cap. I am just finding the velocity along x axis, that will be 5 minus 4t, and acceleration, sir, how you got that? Differentiate x, differentiation of x will give us 5 differentiation of t is 1 and t square 2 will come in front and t to the power 2 minus 1, that is 4t. Velocity of y axis, that will be equals to 10, correct. Let us differentiate it again to get the acceleration along x axis. So, derivative of 5 0 because it is a constant, and derivative of 4t, that is minus 4, ay that will be equals to 0, right. Now, let us write it in a proper vector form, it is minus 4 I cap and plus 0 j cap, right. Now, at t equal to 2 seconds, so there is no t variable in the equation. So, t at any time the acceleration is becoming constant, and that too along which direction? Along horizontal direction, x axis. So, that is minus 4 meter per second square. That is our correct answer. I hope this is clear. Great. Our next problem, again a beautiful problem, a lengthy one, right. So, the position vector of r as a function of time is given by r is given as 4 sine 2 pi t I cap plus 4 cos 2 pi t j cap. Great. Now, here in this problem, where r is in meters, t is in seconds, I and j denotes unit vectors along x and y direction. Which one of the following is wrong? Be very careful which one is wrong for the following motion, right. Now, the first part says acceleration is along minus r. Let us consider each and every part. Let us focus on each and every part. To understand each and every part, you have to focus on differentiation. So, your differentiation should be very clear. Here we will make use of chain rule also. So, focus in case if you do not know the very basic. We know that velocity vector v will be equals to dr by dt, differentiation of r. And here 4 is constant. So, I am taking out and I am just writing d by dt of sine 2 pi t I cap plus 4 outside again d by dt of cos 2 pi t j cap, right. Now, they are saying acceleration. So, we will have to differentiate the velocity once again to get the acceleration. Be very careful with that, right. So, here this will be 4 sine differentiation will give you cos 2 pi t, okay, into sine differentiation is done. Now, chain rule says differentiate 2 pi t. So, that will give us 2 pi I cap plus 4 derivative of cos, sir, minus sine 2 pi t. This is the differentiation of cos, right, and differentiation of 2 pi t, that is 2 pi and j cap, correct. This is our velocity vector, right. So, if you want, I am just writing it as properly here. V will be equals to 4 into 2, 8 pi cos 2 pi t I cap, because later we will require it in option C for velocity vector, right. And here it is minus 8 pi sine 2 pi t j cap, right. Now, let us differentiate it once again to get the acceleration. So, this time I am doing directly because I have already explained you how to differentiate in the first case in the velocity, right. So, 8 pi, and again when you differentiate cos 2 pi you will get minus sine 2 pi t, and 2 pi will be multiplied and you will get 16 pi square I minus 16 pi square cos 2 pi t j cap, right. Let us take let us separate our r here, okay. So, r if I want to separate, let us take 4 pi square common from both. I left with, and minus also is common in both of them. So, this will be 4 sine 2 pi t plus 4 cos 2 pi t. In case if you are confused, let us multiply this 4 pi square back, you will get the green equation. Minus 4 pi square into 4 minus 16 pi square minus 4 pi square into 4 minus 16 pi square, right. And the thing which is written in the bracket is nothing but r vector. So, our first option is absolutely correct. The acceleration is along negative of r. You can see the negative sign, right. Let us see the option B. So, option B I am trying to solve here. Magnitude of acceleration vector is v square by r, where v is the velocity of the particle. Let us find the magnitude v. That will be equals to how much? Root under 8 pi cos 2 pi t whole square plus minus 8 pi sin 2 pi t whole square, right. So, this will give us under root how much? 64 pi square cos square 2 pi t plus 64 pi square sin square 2 pi t, right. This is our B part. Now, here when you take root under 64 pi square common, cos square 2 pi t plus sin square pi 2 pi t, that is 1 from 10th standard. Let me repeat again, cos square 2 pi t plus sin square 2 pi t is 1. So, that will give you 8 pi, that is our velocity, right. This is magnitude of v. Let us find the magnitude of r here. R is on the top, and if you find the magnitude, let me find it over here only, r magnitude. So, magnitude of r over here will be root under that will be 4 4s are 16 sin square plus cos square, that will be again 1. So, that will give us how much? 4. Let me repeat again, magnitude of r will be root under 4 square 16 sin square 2 pi t and plus cos square 2 pi t, that will become 1. So, root 16 is 4. Great. So, r we got as 4. Now, let us see v square by r, that will be our 64 pi square upon 4, that is 16 pi square. And if you look at acceleration vector, here if you find the magnitude of this will give you straight away the same thing, 16 pi square, right. So, option B is also correct. Let us see the option C, magnitude of the velocity is 8 meter per second. Let me check, no, the velocity vector is giving you magnitude as 8 pi meter per second. So, incorrect is this one, clear. And path of the particle is circle. So, of course, this will be circle, you can take it as x, you can take it as y, and you can put it in equation of circle in case if you know x square plus y square equal to r square. So, you will get the radius vector and that too will be 4, right. So, the incorrect statement is option C, the velocity is not 8 meter per second, but it is 8 pi meter per second. I hope this is clear. We will continue from this in the next class, right.